Hello. In this episode, we're going to talk about how to determine the domain and range of some rational functions. And in some cases, we talk about determining the domain of rational functions. And the rational function, the simplest rational function we could think of is f of x equals to 1 over x. In the previous module, we talk about, this function's domain, range, and graph. So for example, if we have a function which is g of x, this is our first example. To determine its domain, we can set x minus 1 not equal to 0. And if x minus 1 is not equal to 0, then x cannot equal to 1. Then the domain would be x is not equal to 0. And the range of this function, of course, it cannot be equal to 0 either. So if you look at the curve will also tell us much about domain and range. And because x cannot equals to 1, right? So 1 is the vertical, x equals to 1 is the vertical asymptote. So let me draw the asymptote. And as a straight line, and this is where the curve will never cross. And you can see the black curve is 1 over x, the red one is 1 over x minus 1. The red one is the shifting of the black one to the right by 1 unit. And the domain is adjusted, and the domain is x not equals to 1, and the range. And you can see that the red curve will never cross the x-axis, so the range is not equal to 0, and the red curve will go as high as possible, and the only number x, the function value cannot be is 0, so that's a domain and range. Let's look at the second example. The second example we're only going to determine the domain of the rational function. About the range of this function, we will you will get to learn this in future courses. To determine the domain, we will set up the denominator not equal to 0, and we'll factor. And so if the product is not 0, then both factors are not 0. So the first factor, x plus 1, cannot be 0, and x minus 2 cannot be 0. In other words, only when both factors are not 0, and that will guarantee the product will be 0, or will not be 0. So the consequence is x is not equals to -1, and x is not equals to +2. So that will be the domain. Okay, so the domain would be, it's really a shorthand notation. Basically says it's all real numbers except the -1 and the -2. Okay, so in words, all real numbers except -1 and +2. Okay, so that's a domain of G in this case. The third example, we would like you to look at this rational function. In the numerator, it's a linear function, and the denominator is x squared minus 9. Well, the numerator can be any real number, and 2x plus 1, indeed, it can be any real number. So to determine a domain, and the denominator cannot be 0. Once again, we're going to solve this equation. Okay, so if x cannot be equals to, if x minus 9 cannot be 0, and that means x squared cannot equals to 9. If x squared cannot be equals to 9, if we take square root on both sides, and we will end up with square root of x squared and the square root of 9. Square root of 9 is 3, and this square root of x squared is absolute value of x. that cannot be equals to 3. As a result, the domain would be x cannot be equals to -3 and x cannot equals to 3. Okay, so the domain would be x cannot equals to -3 or +3. Sometimes we would write it in a shorthand notation like this, okay, meaning the same thing. X cannot equals to plus or minus 3. And in words, the domain is all real numbers except +3 and -3. Okay, so I think that's all for this episode. Thank you for watching.